Today we have a special event for you. We're gonna a little bit of householding first. We're gonna our house. I'm gonna start over because Mike just joined here. So let's record and we'll try it one more time. Hello, Mike.
Hi, Mike.
We're
Mike, I broke a string this semester. Usually when there's a room full of me and students, there's at least one or two other mics. But this semester I didn't have one. So it was very odd.
All right. Well, nice to see you again. And Dave is ready to go. And I'm going to do 3 slides and record, or 3 slides and hit record. Then I'm going to turn my camera off and give it all to him. At the end, we'll come back to me and he's going to do some magic trick with his hands or something.
So I can only be here till about 40 after the hour because I have a 9 o'clock away from home.
Yeah, just
turn off my sound.
Yep. Okay, I'm going to start recording now.
Now you're seeing my slide?
No, not yet. We're seeing mine. And then when I introduce you, then you're going to do the share. Okay, so I have 3 slides and then you share, hit the button, and then start talking.
Hang on. Let me be on. Okay, now I see you guys.
Okay, here we go. Hello, this is the June edition of the Treasure Valley Data Enthusiasts. I'm Mike Migalski, your host, and happy to present some exciting news to you today. First of all, for some housekeeping, if you want to be on our membership list, send an email to tvde@infovia.com. And we're always open for your feedback. We are recording today, and for future topics, we have St. Luke's, Saks, Veronica from Saks, Troy and Chai from St. Luke's next month, and we're always open for other ideas. In today's session, we welcome renowned author and data modeling authority, Mr. Dave Hay, a recent friend of mine, and Dave has been in the IT industry since it was called data processing. He has data models have supported strategic and requirements planning. He's built several books, of which I have a couple of them, specifically Data Model Patterns, Conventions of Thought, and Enterprise Model Patterns. He is an expert in UML and data modeling, and we are really thrilled and honored to have him today. So with that, I'm going to stop sharing, and Dave is going to take over from here all the way from London, UK. Dave, share away.
Okay. Is this shared?
Not seeing you yet.
Okay, it should be the slides. Hang on. Okay, it should be here from your side, and at this point I do. And it asked me what I want to share, but it didn't ask me that. Ah, there we go. Screen window. Let me the window.
I usually do the screen.
That window. Okay.
There we go.
Now,
all right, we see you. You're good.
Okay.
And you're off.
Okay.
I mean, you're on.
Thank you. Thank you all for coming, Harry. I understood this was a DAMA administration outfit, and it's not. It's a local group of enthusiasts, which is great. I understand you're in Boise, Idaho. And as Michael just said, I am in fact coming to you from London, which is a strange thing to be doing. Next. And it's not going to the next slide. Oh, there we go. I am, as he said, David C. Hay. My company's name is Essential Strategies International. I've been doing that for about 40 some years now. And I wager that I am probably older than pretty much all of you, having been born in the second half of the last century, the first half of the last century in 1947. Now, there is one person in our group who is your teacher, Mr. Mike Lynott, who was also born in 1947. But where I was born in a small town in western Colorado named Grand Junction, he was born in a much more industrial city back east called Scranton, Pennsylvania. This also was the year born one Peter Chin, who we'll learn more about a little later. He wasn't born anywhere near us. He was from Taiwan, an industrial city in Taiwan, which in 1947 was trying to figure out whether it was part of China or not. Now, that's the historical part of 47. The stuff that's less interesting is the fact that that year was invented the transistor, which actually turned out to be handy because it was the year before that the first electronic, numerical, integrated, and computer was installed in Pennsylvania, which consisted of hundreds and hundreds of vacuum tubes, which kept burning out. And it was thanks to the transistor and silk that they later finally get something like that working. Now, as I say, this was a small town in western Colorado, population of 20,000, which made it the largest municipality for 250 miles in any direction. It was kind of isolated. My knowledge of the outside world was pretty much limited to newspapers, magazines, the public library. Oh yeah, the odd James Bond movie, but that didn't count. By the time I was 18, I decided I really wanted to learn more about the outside world. So on a beautiful September afternoon, I took my very first commercial airplane ride. 3 hours later, I was by myself in the middle of Los Angeles International Airport at 5 o'clock on a Thursday afternoon trying to find my way to college. College being the Claremont College is some 30, it was reputed to be 30 miles east of Los Angeles. What that meant was 30 miles east of downtown Los Angeles. Los Angeles itself extended way, way beyond that. And I should point out that if you're going to introduce yourself to the outside world, you can't be doing it in Southern California in the second half of the 1960s. The whole world was in chaos at that point. And so my being in chaos was just part of the deal. I think by the time I graduated 4 years later in 1969, I might have adjusted because at that point in my life, what seemed reasonable was to get married on Saturday, graduate from college on Sunday, and set out hitchhiking to New York City on Monday. I mean, didn't we all do that? I was one of several millions of people, of course, who arrived in New York with no job, no money, and no experience. I did happen to have in my pocket a college degree, but alas, that was in philosophy, which actually would be useful 20 years later. In 1969, not so much. However, I did discover that part of the secret to success is dumb luck and the kindness of strangers. And after I was almost lost after 3 days, I met a fellow who dealt with something called computer time sharing. And my experience with computers in college was punch cards and putting in the computer and getting back a set of punch cards, putting that in a computer, discovering it didn't work. And I discovered that this whole computer business was, forget it. That's why I majored in philosophy. But it turned out that in 1969, a year earlier, had been invented this thing called computer time sharing, which meant that you could put your computer in a teletype machine, and see the program right there. And thanks to the wonders of Ma Bell, it would be whizzed out to Long Island somewhere, and there it would be compiled and run and would send data back to you. Now, understand the definition of whizzed in those days was exactly 100 bits per second. A year later, we got to use a fancy plant terminal, and it was 300 bits per second, which that was cool. But needless to say, what I mentioned to the guy was that I had learned how to program in Fortran. And so suddenly I was a hot topic and I had a job. And it was sort of touch and go for a while, but I got another job in a consulting company. and did market research programming for the likes of Lever Brothers and General Foods. And so I went off, and by 1975, I'd acquired a graduate degree, an MBA. Now here, the major was in another useful thing called quantitative analysis, which actually 40 years later would have been handy, but it was still good. I had the MBA, and that meant I got a job with Pfizer. And there I was designing and implementing manufacturing and inventory control systems. This again was a new technology called Material Requirements Planning, or MRP. This was a bit of software that would take a sales forecast for finished products out some number of weeks or months and translate that using the product structure definitions for each of these finished products to come up with an equivalent forecast for their component materials or raw materials. And this was a very clever piece of software that the companies loved to get by. And there were several vendors for this, as you can imagine. But it became very clear to me that some of the vendors understood the nature of the data they were working with, and theirs worked pretty
Dave, if I
well.
could interrupt for 1 second,
Yes.
we're still seeing slide number 2 and it says 1947. So if you're advancing your slides, we're not seeing them.
That's not good. Okay, let's come back.
There
1947.
you go. Yep.
Okay,
I see
my
the
hometown.
change. Yeah. Yep. There we go. Thank you.
Transistor. Los Angeles, New York. My MBA. Are you seeing that? Hello.
Yes,
So you're seeing 1975 to 1986.
that's right.
Okay.
Thank you.
So now, two things interesting came out of this experience. One was it was very clear that companies that understood the structure of the underlying data were way better at solving the problem than those who did not. The second problem was for the company itself that was buying into this, because it turned out that the software could be wonderful, but if you have a forecast of requirements of your components, you have to know how many of those you have on hand. And the inventory of the materials that you're using is a matter of understanding the data and managing the data. And suddenly, even then, we were discovering, managing data turns out to be A, very important, and B, hard. Now, 50 years later, of course, what we've discovered is something very different. What we've discovered is that managing data is A, very important, and B, hard. And some things haven't changed a bit. Meanwhile, computers have come a long way since the ENIAC. There were tape card, punch cards, and there was magnetic tape, which had data in strings. But somewhere in the 60s, they invented the disk drive, which meant that you could get data randomly from various places, which meant that the programmers had great fun making incredibly complex structures. And the whole thing became kind of hopeless. And then in 1971, or 2 years after I got to New York, Ted Codd, as a mathematician, came up with a mathematical theory for minimizing the redundancy in the data and making it more manageable. And this was that you organize data in terms of simple two-dimensional tables. That is, each one has a set of columns that define things and then a number of instances. And it took 5 years for Oracle and other companies to turn that into database management systems that could manage data in that form. Also in 1976, Peter Chen, remember him, came up with a way of describing those tables and columns and how they were related to each other, and came up with the first notation for describing entity relationship models. Now, this notation, again, was sort of keeping with Ted Codd's being a mathematician. It had boxes and lines connecting each other. Relationships were represented by the rhombus shape, and attributes were represented hanging off the side with circles. Not quite as elegant as it could be. But the federal government said, oh, we can do much better than that. And they created their own notation. And if you can imagine the federal government, its various agencies getting involved in trying to come up with something artistic, you can imagine what they came up with. This thing was awful. Now, there are a lot of people who liked it and did very well with it, and but I talked to the fellow who wrote the book on it, and I said, "But how do you present this to business people?" He said, "Oh, I would never present this to business people," and that's part of the problem. Now, the company that was providing that tool decided that it should be a little bit more accessible. So they called upon a fellow named James Martin and his friend from Australia, Clive Finkelstein, and they had come up with a whole way of organizing data, which they called information engineering. And this had to do with how to manage the projects. It also came up with their own notation, which was a bit better than IDF1X, but still with some problems. And I didn't really like data modeling because that was all too complicated. But in 1986, I went to work for Oracle Corporation, and they had come up with a way of representing data that was wonderful because you could, first of all, it used language, and we'll talk about that in a moment. Secondly, it set up the aesthetics so that a business person could understand what was there. And so suddenly you, as a modeler, were presenting a representation of the business, and the subject matter expert of the business was saying, yeah, that's right. No, that's not right, and so on. And you should understand, by the way, I was at Oracle, and I was sort of lost with the Oracle database. But this fellow, Mike Lynott, that you guys have met, told me about data modeling, and I spent a week in Ottawa with him explaining all of this. So those of you in his classes represented that you're in good history. Okay, I wound up using this technique with several clients over the years, and I discovered something, and that is that if you did a representation of something about the business, and you had another client that has the same set of business, the representation was the same. And I came up with about a dozen models that I was able to put together in a package as a set of standard models for standard business situations. This was in 1995. Basically, I was following my nose and just doing what seemed reasonable, and I was startled to discover that year, that book was the first of its kind. Now, several followed on beyond that, but that was the first in the business. So there you are. In particular, the fellow Oracle person and I came up with a response to that, which my problem with his was that they were sort of too detailed, and you didn't have the advantage of its being general enough to apply to different situations. But over the years in between, I discovered that I also was getting in more detail. And so in 2011, I came up with the enterprise model patterns describing the world. And here I specifically addressed different levels of abstraction. So the level one was basically what I'd done in the first book. Level two was more specific to departments. And level three was generic models for industries like the oil industry, banking, building highways, and so on. Now, by the way, level zero, which we're not going to get to today, but level zero is fun because that's a template for the level one standard metals. But there are two meta models. One is accounting, because accounting turns out to be a model of the whole business. And the second was information resources, which think books or documents. Each one of these may have a physical manifestation, but it's about something else, the whole rest of the model. But that's level zero. Anyway, 2011, I published this book. Now, at that point, I had been hanging out much too long with a group called the Object Management Group. And this was a group of people who were programming in the object world, what they call the object world. object-oriented programming, which is very different from the commercial programming that we were working with. And they had different problems to deal with. They came up with their own unified modeling language, otherwise known as UML, which I couldn't make sense of for the longest time. And finally, I figured out that, yeah, it's because they're doing something different. And that's the subject of our presentation today, is what is it that they were doing and how can we make use of it? Because I wound up using that notation in my enterprise model patterns book as well. Anyway, in between two other books, one on requirements analysis, which we're going to talk about in a minute, and one on metadata, which we're not going to talk about at all. And then finally, more recently, something called Achieving Buzzword Compliance. This book came from my experience with my colleagues' experiences of going into client sites and saying, you don't really use language very well because you got the same word, you means 3 or 4 different things. The same concept has 3 or 4 different words for it. We're here to help. And my colleagues and I made very good money at doing that, you should know. However, there's this problem in our own field. What do we mean by a conceptual data model? Well, I have at least 3 different definitions of that. What do we mean by a semantic data model? Well, that depends on who you're talking to. How about a logical data model? Well, there you have it. Well, this book attempts to address the problem in our own industry. And if you're interested, by the way, if you go to YouTube and look for Dave Hay Buzzwords, you will find a 2-part version of that book. Actually, 2 copies of it, but very identical. All right. Some of you in the room are specialists in data modeling, given your good students of Mr. Lynett here. Others have been out in the world and have learned how to program and model in UML. The data modelers are 2 flavors. You are modeling in order to design databases. And, sorry. Others of you want to get a picture of the company itself, the semantics of the business. On the UML side, some of you are object-oriented designers, designing object-oriented systems. And there are others that have other interests. Okay, now for those of you in the room who have experience in data modeling, first of all, I should explain that I'm calling those of you entity relationship modelers or ER modelers, but there are 2 sets of you. One is database designers, as I mentioned, and recognizing that object-oriented design is completely different. A lot of articles about impedance mismatches. They're just the wrong things. And UML is evil. Okay, those of you who have experience modeling sort of the business, the semantics of the business, UML doesn't understand the business. UML is evil. Okay, that's where we sit as data modelers. First of all, there's a problem. Unified modeling language, otherwise known as UML, is here. It's widely recognized as a standard. Clients and hiring managers want to hear if you know UML. What do you mean by UML? Well, it has something called class models, and these can be about anything. An object is defined as any discrete entity with well-defined boundary and identity that encapsulates state and behavior. Say what? Well, it's an instance of a class. Okay, so what do you mean by class? Well, class obviously is a set of objects. Now, some of you may know the word tautology, and then you may have gone to the dictionary to find out the definition of tautology, and the definition, of course, see tautology. It means you're defining something in terms of itself. Well, this is a little bit more defined than what we see here. There's the same attribute. There's same attributes, operations, which is like programming operations, associations, relationships among themselves, methods, which is what the operations are supposed to accomplish, and behavior, which is all of these objects will behave in the same way. Now, for UML information for this purposes of this presentation, I refer to James Rumbaugh, Errol Jacobson, and Grady Booch, which back in those days, there was a great movie out about the Three Amigos, and people are calling them the Three Amigos. Several books they wrote. One is the Unified Modeling Language Reference Manual, and that's where everything you see here came from. Now, entity classes, how do they differ between object-oriented classes? In UML, a class, as I said, is any kind of thing. It can be a business object, like what we talk about, or a technology object. It could be a piece of program code. Think about the little critters in video games. Each one of those is an object. Any noun can be used. An entity type that we're going to talk about here, is a subset of the UML concept of class. It's only those that are about business objects. A class for us is a group of things of significance to the business. UML began, as I say, to support object-oriented design. It's not a single notation. It's an array of technical notations for classes and associations, activities, class behaviors, states, and events. So that is an object is in one state and moves to another state because something happened. Again, these books are from Rumbaugh. Now, for data model, it can be done. We can use the UML notation if we apply a certain discipline to it. UML is extensive. We can take a subset. It has some quirks, but you can get around them. Well, the UML notation itself is not beautiful. And we're kind of stuck because we're talking about that notation here. We're going to make use of it, but there's some things we can do. But that's what we got. Okay, the premise of today's presentation: an entity relationship model is not the same thing as a class model in UML. However, it is valuable to learn new ways to do things. You can learn to improve your modeling no matter what notation you use. Okay, for those of you in the room who are UML modelers, an entity relationship model is different. It's only concerned with entity classes that pertain to the business at hand. It uses only a subset of the notation that's used in UML. It's concerned with classes, and specifically UML classes are related to something called an entity relationships, an entity class, but business things only. Now, UML has something called a role, which is how it implements associations. Okay, the relationship has an end, which is an assertion about the nature of the relationship. It's not the same as the UML role. We're going to learn about that in the next few minutes. An attribute, well, these are the same in both cases. Language is used differently. In an ER model, normal English entity classes and attribute names, including spaces between words. Nothing okay there. Now, there are some classes of ER modeling which is based on relational databases, and they have underscores and all kinds of stuff like that, but we're interested in the normal English version. Now, a role in entity relationship modeling is a business assertion. It's the nature of the relationship. It's not a label for something else. We'll see that in a few minutes. In our case, the relationship is about the structure of the relationship between these things. Think bridge. UML association is about behavior. How does this class interact with that class? It's the interaction that is what's big in UML. Okay, modeling for requirements analysis. Understand systems analysis is 20 years older than UML. UML's only been around since 1999. Any relationship modeling that I mentioned started with Peter Chen, was 1976. And then data flow diagrams. Now, I mentioned I went to work for Pfizer when I got my MBA in 75. My first job at Pfizer was to go to a plant, and they start with work orders, and each work order starts with the plant manager, and it gets marked up and gets handed off to the next person who that's marked up, and that gets handed off, and so on and so forth. And so basically, by the end of a production lot, you had 12 copies of a work order. And it seemed to me there ought to be a way to describe what's going on. And so I basically had to invent my own idea of data process models. I did not bad, but not well. And I was really grateful that in '79, Chris Sorson and Chris Game came up with the answer. And their data flow diagrams were exactly what I was looking for before. Their notation had boxes that represent the external entities that are the source of all data, and external entities that are where all the data wind up. And then in between, there are passage of data from the sources to a process to a data store, which is to say, like, for example, a work order that's been marked up, and then the marked up work store, data store gets passed on to somebody else, and so on. And they started with the idea that you have a diagram of what's going on physically, and then you convert that to what they call the logical data flow diagram, which is without the physical technologies and just what's going on with the data. The problem is they were kind of squishy on what this transition looks like, but two of their colleagues came up with something they called the essential data flow diagrams. This is Steve Pullman and John Palmer in 1984. And this was brilliant because it was exactly what was going on. You take the physical processes and break them down into fragments of processes, and you get to the lowest level of fragments. You take something that happens, like somebody comes and wants to buy something. And what are the set of fragments that are the response to that, and that ultimately result in something being bought on the other side? You gather together all those fragments of the response to an essential event, and you got an essential process. And that was very tidy and very neat. And from then on, I liked the idea of an essential diagram. And when I came up for a company name, essential became the company name. Now, modeling for analysis about the business, the problem space, which is not about the technology, which is the solution space. For example, there is no such thing as object-oriented systems analysis. I know there are several books by that title. This is wrong. There is systems analysis. What are the problems in the business? What do we need to fix them? All right, then you look at, okay, what can we use to fix them? Well, the technology may be object-oriented technology. It may be relational databases. It may be COBOL. There are all kinds of different technology that solve them. But the idea is to come up with analysis. You understand the problems first before you get involved in that technology. Now, premise. A class model in UML is not the same as an entity relationship model. However, it is valuable to learn new ways to do things. You can learn to improve your modeling no matter what notation you use. Are we hearing something? Is there a repetition going on? Well, by the way, you should understand there are better and worse data modelers. People who know how to do it, people not so much. Better and worse UML modelers, same idea. And neither commodity is what you would call homogeneous. If you're in a data administration group, a professional society, you've already learned this. The objective of this presentation is to provide all modelers guidance to produce an excellent entity relationship diagram that happens to use the UML class notation. So for today, what are we going to do? I said this is based on my book on the subject, UML and Data Modeling, a Reconciliation. It was published in 2011, based on work that I did with the Object Management Group, as well as my own history. It's used, and I use this version of UML that you're going to learn in today as the notation for my enterprise model patterns. When I told my data model friends that I was going to use UML in this book, they were horrified. And I talked to my object-oriented, my OMG people that I was going to use in a book. They were, you're going to stretch UML to both groups? Yes. And I think it's not bad. So I leave that to you. At the end of the presentation, you'll have a chance to get a copy of this. Okay, what are the elements of great models? First of all, we're going to compare notation between the two techniques, compare how the two use language, how they address supertypes and subtypes, how they address domains, what's unnecessary and missing from UML, and we'll talk about aesthetics. Okay, notation. We have two different elements in the notations. First, entity types and classes, and second, relationships and associations. Entity types and classes. Okay, harking back to our friend Peter Chen, entity is a thing of significance about which you wish to hold information. This mouse is an entity. This computer is an entity. This person is an entity. The room you're in is an entity. Entity type is a class of those things. Okay, so person or room or computer, these are classes, and this is what we're going to draw pictures of. So here are a set of classes. And note that this distinction originated with Peter Chen in 76. So for example, vendor is a class of things, and it's defined as a person or organization that wants to sell us something. Okay, once you've got one of those classes, then how are you going to describe that class? Well, attributes are the definitions of elements of that information. So here you have an identifier of the vendor and then a name and a street address. And the same applies to all of these. There are attributes. Now you may note that we have boxes inside boxes, which is a particular way that this notation describes subtypes. And think of this as a Venn diagram. If you have a geographic area that is defined as a bounded area on, for example, the Earth, and a city is a kind of geographic area where the boundaries are established by, say, local states. So the way these boundaries were defined by the state of Idaho. State, for example, like Idaho, the boundaries are defined by the federal government, and the country boundaries are defined by treaty, some sort of international treaty. Now, these entity types are defined in the same. So it's not people, it's person, it's product types, it's product type. You're not allowing things like project history, because history is not a thing. It's a collection of things. Think about project, that's the thing itself. The employee table means that you've been talking to the database people. It's not the table, it's the employee that is the center of this. However, employee is not really an entity because you're not born an employee. The entity you're interested in is a person who, when he gets to be 18, finally gets a job. And so the job is an association with an organization. And so the employment is the fact that a person is working for a company. Zip code comes up a lot in conversations, at least in the United States, but that is a trademark from the U.S. Postal Service for an identifier of a geographical area. Remember geographic area? Well, one of the geographic areas is a postal area. And if, for example, you log on to, you try to set up an account with Walmart, the first thing they want to know is what's your zip code, because that tells you what postal area, what part of the country you're located in. So it's not really zip code. If you're being international, call it postal district, because that's the thing that you're really concerned with. So an entity type is a set of entities described by a set of attributes without concern for anything else. When the UML people came along, they claimed it was superior because data modelers don't understand the difference between objects and classes. Well, no. A UML object really does correspond to a data model entity. A UML class does correspond to a data model entity type, or I'm happy to call you an entity class. In fact, from here on, we'll talk about entity classes just to sort of clarify. Attributes, and in both cases, this is a characteristic that quantifies how many qualifies what color, identifies which one, classifies what category, or expresses the state, what status it in. And these are kinds of attributes that you'll have. Again, a simple English name, including spaces. One may choose not to display attributes because it clutters up the around, which is true. If it's display, you must at least display the name and some representation of whether it's optional or not. If you want, you can display the data type, but that's beginning to make them all a little bit complicated. Don't display anything else. Okay, relationships and associations. Here's the place where things get tricky, because you have entity types and they have lines connecting them with odd symbols on the lines and words, bits of words. If you've been using the information engineering model, you notice that they have words also, but the words are different here. And this whole approach was developed by two Brits in my neighborhood here as we speak, Richard Barker and Harry Ellis. And unlike any of the other notations that you found, there is a discipline involved in how to name these things. These are assertions about what an instance of this type has to do with instances of that type. And note that they're in both directions. Okay, this one has this, and this one has this, and there are rules for forming and naming those relationships. Each relationship is going to produce a very strong sentence. So, for example, on this diagram, hiding from you, each sales order may be composed of one or more SO line items, each of which must be to sell one and only one product type. Now, this is what you present to a business subject matter expert. Is this statement true or not? Can you have a sales order that has no line items? Well, depending on the company, you may. Must be sell one only one product type? Well, it's the nature of an order. The line item is for one and only one product type. But what about for a service, something else? The point is that this is the subject of the conversation that you as a modeler have with your subject matter expert. You should know that this statement comes from this drawing. Each sales order may be, because it's a dash line, composed of, and because there's a little funny curlicue there, we call a crow's foot, one or more SO line items. Each of these, in turn, must be to sell, and because there's no symbol down here, it's one and only one product type. Okay, so there is an exact mapping between this drawing and this sentence. So each first entity type must be, if it's a solid line, or maybe if it's a dash line. Now, composed of, there's a rule behind how you come up with a relationship name. We're going to talk about that in a minute. But this is very important. One and only one, or one or more of the second entity type. This is how you come up with the syntax for the language of those relationships. And this is a much more disciplined syntax than you'll find in any other notations. For example, here you have each order must be, because it's a solid line, two, and then one only one party. So each order must be two, one only one party. Each party, on the other hand, may be, because it's a dash line, the seller in one or more orders. And again, each order must be from one only one party. And each party may be the customer in one or more orders. So here you have simple English sentences. Now, the truth of these sentences is not the modeler, it's the subject matter experts. So, for example, you have each order must be to one and only one seller, one and only one vendor, but you often have an order that is to a set of vendors. You have the customer. You often have an order that is to a set of customers. So you may want to change this one and only one to a crow's foot, one or more, one or more. because this is truly a many-to-many relationship, which is a different subject we'll talk about in a moment. But the point is that this getting marked up is what that happens. And the measure of how successful you've been in your presentation of your models is how much they've been marked up. We'll talk more about that in a moment. Now, the role is part of an assertion about the universal discourse. Its form is a subject entity class. Now, for those of you involved in the semantic web, you've seen this before. The subject entity class, the predicate, which is a role, and the object entity class. In UML, the role is what the entity class means to the other entity class. It's not the same thing at all. Now, the biggest issue here is about behavior. UML addresses behavior. ER modeling specifically does not, or should not. We're going to talk about that in a moment, too. Object-oriented design bundles with each class the program code for creating, manipulating, or destroying instances of that class. That is, the definition of the class, along with attributes, you have the behaviors for that class. Not in ER modeling. Behavior is not appropriate. We only have had one verb, to be, which is either must be or maybe, and that's the only verb we're going to talk about. The content of the predicate must be a preposition. Now, here's where the British folks were smarter than anybody that went before, because preposition is the part of speech that describes relationships. Now, Grover had over, under, around. There were activity words called verbs, which were jumps, plays, runs, throws things. Note that when we were learning this, by the way, this is what we were supposed to learn in grade school. And I remember learning in grade school, a preposition isn't something you should end a sentence with. Don't end a sentence with a preposition. So that's not this. Anyway. The preposition is the secret to our presentation today. Now, UML has something called namespaces. And I realize we're getting out of time. If you guys have to leave, that's okay. For purposes of the recording, I will continue. In object-oriented design, names may be defined and used. Within a namespace, each name has a unique meaning. All named elements are declared as being in that space, and their names have a scope within it. Okay, I'm supposed to be half an hour. Well, sorry about that. The UML version. Each
Dave,
order is from. Yeah.
I'm going to let the recording continue to run. So you're good.
Okay.
Thanks.
Okay. The each order is from exactly one something and exactly to something. It's to exactly one something. Note the related class itself may not be part of the source class's namespace. That makes it sort of ugly. Well, now from what? What is that? To what is that? Well, there's something there. And here, for example, you have a party is a customer in 0 or more something. Each party is a vendor in 0 or more something. Now, what UML does is it names these as roles, which makes you a little easier. So each order, or something here is playing the role of being a customer for one order. Each something is playing the role of being a vendor for one order. And here, each something is playing the role of being a purchase order for 0 or more parties, sales order for 0 or more parties. Okay, this is a little clumsy. The related class may not be part of the source class's namespace. Now here we have a ER model that we know. Okay, each entity may be contained in one or more subject areas. Each subject area, and that, by the way, the contained subject area is a predicate for the entity. Each subject area may be container of one or more entities. and the container itself is a predicate for the subject area. Okay, UML roles, on the other hand, has something like this. Each entity has 0 or more containing subject areas. Now, containing subject area is a property of entity. Subject area itself cannot be a property of entity, so it's invisible to the entity. Each subject area is 0 or more contained entities. And contained entity is a property of subject area. But entity cannot be a property of subject area. Okay, here's the ER version. What we're going to do here is take the Barker-Ellis language, but use the UML notation, which means that each order must be one and only one party. Okay, each party, on the other hand, may be a customer in one or more orders. Each order must be to one and only one party. Each party, on the other hand, may be a vendor in one or more orders. You may have seen these sentences before. These are exactly the same sentences we saw before, but the notation is different. And they're exactly the same sentences. And the truth of each statement is the subject matter experts. It's not the data modeler. So what we can do in UML is name roles like this. Each entity class 1 must be, if the second entity class has a 1 dot dot next to it, or maybe if the second entity class has a 0 dot dot next to it. And the role name, same roles for role names, we'll talk about that in a moment. One or more, second entity class has a star next to it, or one and only one has a 1 next to it in the second entity class. So here you have the two notations, but they're the same thing. Now each order may be composed of one or more line items. Note that the optionality is near the subject end, or composed of one or more line items. So here, each order may be composed of one or more line items. Optionality is near the object end. All right, this can be confusing, and so for that reason, if you use both notations, everything goes clockwise. The composed of goes like this, composed of goes like this. So each line item must be part of one and only one order. And sure enough, each line item must be part of one and only one order. Zero sanity of all sentences are really read clockwise. Now, whether these attributes are optional or not. In the case of Oracle's ER notations, either star or a hashtag is mandatory. And in UML, it's the same for attributes as for the relationships. Now, the case rule that I use, if it says 1 dash dash 1, it always collapses up to 1. So 1 means 1 dot dot 1. So it must be one and only one line number. Now, the hashtag is a unique identifier. We're going to talk more about that later. Delivery date is an optional line item. May or may not have a delivery date. Note that the line item may never have more than one, because in the relational world, you can never have more than one value for an attribute. It's got to be 0 dot dot 1. As we know, UML has separate symbols, roles that mean composed of. UML models are not labeled, so it's useful. Error models are always labeled, composed of and part of. These symbols do represent 2/3 of the referential integrity constraints. So the first, delete cascade, to delete the whole is to delete all parts. Second, delete nullify, delete the whole, leaves parts but they're unconnected. There is no such thing as deletion is not permitted. that referential integrity is not available. So no, this syllogism here we don't need because we have it in the language. All names are important. Okay, the Hitchhiker's Guide to the Galaxy has a serious flaw. Ravenous bug bladder beasts often make a very good meal for visiting tourists. This is Douglas Adams' book on the restaurant at the end of the universe. This was a mistake. Tourists think, "Oh wow, I'm going to like bug bladder beasts." That was a mistake. What it was supposed to say is bug bladder beasts make a very good meal of visiting tourists. Bad idea. Not the same. Language is important. The model is a graphic portrayal of assertions about the structure of the business. Feedback sessions is the English sentences that are validated, not the drawing. Right sentences seem self-evident, or they're clearly true or untrue. Getting the English language sentences is hard, however. Note, great literature is a pleasure, or at least interesting to read. On the other hand, great literature is very, very difficult to produce. While an information technology education is useful for some of you, education in literature, history, philosophy, etc., that is to say, learning how to use language, is also very important. Colors. Okay, those of you doing information engineering, it has been misleading you for many years. Relationship names are not verbs. They describe the structure of the relationship between two things, not how one thing interacts with the other. That's object-oriented behavior. Okay, you're a lot closer to being object-oriented than you think, but this is not what we're doing in this case. And this is from Steve Horan, who is a great teacher of data modeling. Each student, and now this is the information engineering notation. So each student attends 0, 1, or more attendances. And each class contains 0, 1, or more attendances. Now this says that attendance apparently must be something attended by, must be a class, but you can't tell from this descriptions. These are actions and they're only in one direction. We can take the Harry Ellis Richard Barker rules and say, well, in attendance, if you think of what is an attendance, well, it's by one or more students. Oh, I'm sorry, attendance is the attendance by one student, and it's the attendance in one class. So this one of these is by one in a class, and a student is many, can participate in many classes. A class may be composed of many attendances. No verbs. Super and subtypes. Now you've seen this. Yeah. So each person is by definition and intents of a party. Each organization by definition is instance of an organization. And the class tools recognize this. And with those class tools, if you put box inside boxes, and they'll recognize you mean inheritance. Now UML inheritance is these classes are related to this class because they are inherited. And this class is related to this one because it's got inheritance. What this means is you have a very busy, unpleasant thing, and you don't have this realization that, well, by definition, a person is a party. By definition, a company is an organization. It's not quite so obvious when you do it this way. Now, in the case tool, I was able to kind of manage it so that the subtypes were inside the supertypes, but it didn't recognize that it was by definition inheritance. So I had to add the inheritance relationships, but for purposes of the aesthetics, this works just fine. Multiple inheritance. Okay, people will tell you, but what if an organization is not only just a party, it may be something else? What if a government is not just an organization, it's something else? Well, it's true that if you do this, you can't have multiple inheritance. But it turns out that by definition, the subtype is a supertype. Think, what is the definition? Aristotle screwed up a lot of different things, but he got language right, and he got definitions right. If you want to define a term, what category is it in? Okay, there's a single category that it belongs to. For example, an automobile is defined as a kind of vehicle. What makes it different from all others in that category? What differentiates it? Okay, a kind of vehicle that is used to carry passengers over land. It's not used for carrying freight. It's not used for carrying passengers over water. It specifically carry passengers over land. So a city by definition is a geographic area. A state by definition is a geographic area. Country by definition is a geographic area. Domains. The inner world, an attribute has a data type. It's also described a category for a set of attributes called a domain. Data type is one of those, but also it could be a list of values, could be a range. It has to be less than or not less than, not greater than. There might be edit rules. These are all the things that define the domain of that attribute. Mathematical expression, which is an extension of the edit rules. UML does not talk about domains. However, they're going one better. They do have a data type which is extensible, so it can cover pretty much the same territory. They also have something else that is way better than we have, which is called well, here you have, okay, in our case, we have this organization is embodied in one or more. This organization is an example of one organization type. Type is embodied in one or more organizations. Now that means that the type has to have a set of attributes. And the attributes wind up being documented separately. Well, UML has a clever thing called an enumeration. Now here, the list of values is itself a property of the class. So instead of the attributes, what you get is a list of the values. So organization has something called an organization type, which is defined as enumeration, which has values this way. That's actually fairly clever. Okay, UML relational design is based on identifying each instance. For example, it could be an attribute. Order is defined by order number, or it could be a relationship to order edit types. Okay, line number is unique, but only in the context of the order that it's in. So for order number ABC, line number 1 is different than for order number XYZ. So the unique identifier is a combination of those two. Now UML, for a long time, decided that they didn't need to do anything, that by definition, objects have to be discrete and distinguishable from each other. Each object has an identifier, which is its conceptual handle. It's an inherent characteristic that it says that object is unique in the whole universe. You don't really need addresses or keys to describe it. So every class contains an inferred system-generated unique identifier. Well, that sounds fine, but in the commercial world, that really doesn't help. Yes, it would be great if you had your person identifier was unique across the universe, but it doesn't usually work that way. So we have to decide whether it's a identifier just for this context or an identifier more generally. However, in recent years, the UML people recognize that it's nice to be able to recognize an ID in context. And so they've defined they call it stereotype, And so this shows up next to an attribute, or it shows up next to a relationship. Aesthetics. This is bad. I have to give credit to Peter Ecken for coming up with this wonderful bad example. I've had clients who ask for something like this. One in particular had it on his wall, and he had his fellow vice presidents from other companies. Oh, that's cool. You have well, what does it mean? Well, your vice president doesn't actually know. Now, there are two things going on here. One is too many boxes, and second is you've got too many lines going different directions. In the too many boxes thing, it was in 1956 that George Miller came up with an essay, Magical Number 7 plus or minus 2, Limits on Our Capacity for Processing Information. The point is, if you have, for example, a PowerPoint slide that has just 2 or 3 boxes, it's sort of trivial. If it has 7 boxes or a bunch of text, that's, puts you to sleep. If it has, 7 plus or minus 2, fine, that's something you can work with. Phone numbers used to be, well, my refrigerant was only 5 digits, but for the longest time it had an exchange and then 4 digits, and area codes were sort of new, and so Colorado was 303, New York was 212, and so on. You happen to know what those were. But then area codes, they ran out of area codes, and so suddenly they had to have a 0 used area codes that had 1 or 3 or 5 in the middle, and the exchange could have zeros and ones. So suddenly you have to know all 10 digits of the area code, and that's too much. Unfortunately, just in the nick of time, you had your cell phone that remembers them, so you don't have to. Okay, vent lines are bad. Expected measurement is the source of measurement, or is it defined by test type? Or is it the collector of a sample? Okay, you have cross lines, and this is way over here. And this person is collecting a sample way down here. Bad. These are only 7 boxes. But what's the subject of the model? Never tell. Straight lines are better. Okay, each of these is between 2 and only 2 things. So test type is defined by expected measurement. Variable is an item for exit. Variable. Better yet, move the mini to the upper left. What this means is that you suddenly have these are typically time. These are transactions. So each transaction has a single something, or we might have one of several things. But the reference data are relatively stable. And there you have it. And this is clinical research. Person is a collector of a sample. Sample is subjected to a test, which is given in a test, which is an example of a test type. The source of measurement is in terms of a variable. Yes, this is clinical research. Okay, where to buy the books? UML, if you go to technicspub.com and look up UML and data modeling, or if you go to technicspub.com and look up enterprise data modeling, for that matter, while you're at it, if you go to look up achieving customer compliance, if you mention my name and mention the code Dave Hay 30, you get a 30% discount. Questions? Okay. Unfortunately, you can't do that. I should have mentioned here Dave Hay. Actually, do it this way, dave@davehay.com. That's easy if you can remember that. Feel free to write to me about anything that's been said here. And,
Thank you, Dave.
I'm going to answer it.
thank you for presenting to us today, and that concludes today's Treasure Valley Data Enthusiasts. Next month we will
Actually, I
have
have
Troy.
one last thing before you go. I would like to highlight myself.
He's on days off, and I really like having him in the office, so I can check in with him.
Are you gonna show us a magic trick?
It's not exactly a trick. Okay, basically, when you go into a company, this is pretty much what the data looks like. And your client will say, "Oh, that's way too complicated. We don't even understand what's going on." But it turns out, if you look at it, there's heading underneath, there are structures. And you can take advantage of the structures.
Oh, okay. He's gone back out to his car. I've got a minute or two here and then. Sorry about that. It's not convenient timing. So Jamie, when you say coding, you mentioned a lot of times I will code that. What do you mean by that? Are you doing some scripting inside of the VA tool?
To get data to translate ways that we want it to translate. I'll use the JavaScripting, things like that. I tend to build out towards our business process. So if depending on what they're doing, what they're needing, what the report's for, I choose, like I could do it other ways. I could treat this tool more like a data warehouse, but I choose to format things in a specific way for whatever the business need is that day. And it helps with security too, because then I know like I'm not putting in information that people shouldn't have access to, and it helps me keep those controls in place. So helps me keep the data secure to manage the reports towards the business process. And I'll use JavaScript, things like that.
Appreciate you.
Copy, but it's usually
That's very artistic.
That's the end of my presentation.
Data I know.
Japanese origami to end your presentation. Right. Well, thank you so much. I've got.
So you have somebody with you to ask questions. Who is that?
I've got two of your books right here, and I appreciate your speaking with us today. I'm going to stop the recording.
Okay, thank you.
He's muted. He might have stepped away again.